Welcome to the lesson on linear equations. In this lesson, you're going to learn on how to draw straight line graphs. You're also going to learn on how to calculate the gradients of a straight line given 2 points or coordinates. You're going to look at something to do with the x and y intercept. And also you're going to look at the equations of straight lines in the form y is equals to mx plus c. I'm also going to look at other forms of equations as well as rearranging equations which are not in the form y is equals to mx plus c. The first thing that you're going to begin, as you have introduced, is the straight line graphs. So the learning objectives of the lesson: by the end of the lesson you should be able to draw graphs by using coordinate table. The outcomes: we should be able to understand the key points of drawing a straight line, or the process that is used or followed when drawing a straight line. And we should also be able to plot a straight line graph. So we go directly to how do we draw a straight line graph, which is given in the form y is equals to mx plus c. So there are three key things that you require when you're drawing a straight line graph. Number one, you require to have a table of values. Prepare a table of values. A table of values is the one that looks like this. And you can see where you have the x and y coordinates. X and y this one is a table of values. So that is the first thing that you require for you to be able to draw a straight line graph. Then number two, you require to have at least 3 points. Any 3 points for you to be able to draw a straight line. And lastly, you need to plot and obtain your straight line using the 3 points that you have. So you're going to use these examples that you're given here to see the process of drawing a straight line. So let's say you're given this equation y is equals to 3x plus 1, and you are required to draw a straight line graph from it. So how do you begin? The first thing is to draw a table of values x and y. You draw that table. Then you think of any 3 points, any 3 values of x that you want to have, any 3 values of x that you wish to use for your line. In this case, you can think of -2. We've used -2, 0, and 2. Now we're going to use this equation to obtain the values of y. After filling the values of x, let us now use this equation to obtain the values of y. So for you to get the values of y, you need to substitute. When x is -2, go to your equation and substitute this value of x here with -2. You will have 3 times -2, which will give you -6 plus 1, you get -5. When x is 0, you come and substitute your x value with 0 there, and you get that is 0 plus 1, which is 1. Then for the other value, that is 1, when x is 2, come and substitute the value of x here with 2. You get 3 times 2 plus 1, which will give you 7. So now you have the values of x and you have the values of y. These are the ones that you're going to plot here on your graph. So as you know, I hope you understand or remember the Cartesian plane, where you have the x, the y-axis, and the x-axis. So this is the y-axis, this is the x-axis. So come and plot them. -2. When x is -2, you come to the x-axis, where x is -2. -2 is here. And then y is -5. Y is -5. So you find the point is somewhere here. That is where the first point is. Then the other point, 0, 1. When x is 0, 0 is here. Y will be 1. Y will be 1. So the other point is here. You're looking at this line that is in green. That is in green color. So and the last point is 2. When x is 2, when x is 2 here, y is 7. Y is 7. So the third point is here. So you can see the first point is here. The second point is here. The third point is here. So what you do, you just join the 3 points using a straight line. And by that, you're able to obtain your linear graph. So that is what you'll do for all the others that are here for this table. These are colors. You can see the lines are drawn using different colors, as well as the tables of values. So The line that you can see in green here, the table that has been used to draw that line is the one that where you can see the values are in green color. The one in red, values are red, the line is here. Then the white one, the values are in white here, and the line is here, and so on. So that is what you do. Simple as that when you're drawing the straight line graphs. So as we've said, the key points that you're supposed to remember when you're drawing any straight line graph is make a table of values, then get the 3 points or the 3 coordinates, then use those 3 points to draw a line. Thank you. So let's go to the gradient of a line. The gradient of a line. So the objective, this part, we should be able to explain how to calculate the gradient using a right angled triangle. Then there's something that you're supposed to note here. What is gradient? What is gradient? Now you see we're talking of gradient of a line. Maybe you don't understand what is gradient is the change in vertical height divided by the change in the horizontal distance. So gradient is simply the slope. So what I've given here in the note is simply like the formula that you use for calculating the gradient. The change in the vertical height divided by the change in the horizontal distance. So we're going to see that as we proceed in the next slides. So we're still in gradient. So this is the formula. The gradient is the measure of steepness of a line. That is the definition. As I've said, gradient is like a slope. It is the measure of the steepness of a line. How steep is that line? That is what we refer to as the gradient. Now, for us to get gradient, these are important note that we need to understand of the formula. Gradient is given by the change in the vertical height divided by the change in the horizontal distance. That is V over H. A difference in the y coordinate, maybe you can call it like that, the V or the vertical height. You can call it the difference in the y coordinates, and therefore for the horizontal distance, you can call that one difference in the x coordinate. Now when you look at this graph, these are 4 lines, and these 4 lines have different gradients. As you can see, I've tried to match the lines. This M refers for the gradient. This is a gradient. You can see the color. You can try to match this color of M with any line that is here, and you can see this M matches with that. So this is the gradient for this line. So we have said that gradient is equals to the vertical distance over the horizontal distance, or the change in the vertical height divided by the change in the horizontal distance. So in this case, for example, in this line that is here, whose gradient is given by 3 over 4, as you can see here. How do we get this 3 over 4? We look at the vertical distance. The vertical distance, as you can see, there are 3 squares. This is where the line meets the x-axis. So you go up how many? These are 3 squares. 1, 2, 3. 3 squares. That is a change in the vertical distance divided by the change in the horizontal distance. Horizontal distance is from here. This is 1, 2, 3, 4. There are 4 squares. So you can see the vertical height. There is a displacement of 3 squares in the vertical height, and then the horizontal distance, there is displacement of 4 squares. So that is how we obtain the gradient. We can do one more in this part. Let's go for this one in red. The one in red here, the gradient is given here. So to get the gradient, you get the vertical displacement or the change in the vertical height, which is from here you have 1, 2, 3. There are 3 squares of a change in the horizontal distance. You can see 1, 2. There are 2 squares. So that is how you do to the other lines, the other 2 lines that are there. Now, how do we calculate? We want to continue and calculate the gradient. And in this part, I want us to learn about the positive and the negative gradient using the coordinates. Gradient can be positive or it can be negative. So we should be able to understand the gradient formula. That is very important. We should also be able to calculate the gradient given 2 coordinates or points. Those are the outcomes that you expect and the objective for this part. So let's look at this diagram that is here. You can see this one is the y-axis and the x-axis is there. Then there's a line here which you're going to use for calculating or showing how we calculate the gradient. So we've said in the previous slide that gradient is given by the change in the vertical distance over or divided by the change in the horizontal distance. So when you look at this line that is here, you'll be able to see that the horizontal displacement is given by x2 minus x1, and this is how you obtain it. From this point to this point, you can see here this is x1, and from this point all the way to the end there, that is x2. So to get this distance that is here, the horizontal distance here, it will be x2 is one from here to this point, x2 minus x1. That is how we obtain this. For the vertical distance from here at the point of intersection, that is from 0, the origin, to the end there, this is y2. Then from this point to this point, this is y1. So therefore, to obtain this height from this point to this point, this one will be y2 minus y1. This one will be represented by y2 minus y1. Therefore, this point is represented by the coordinate x2, y2. This point that is here is represented by the coordinate x1, y1. So we are going to use those points to calculate the gradient of this line. So if you are calculating the gradient of this line, let's say the change in the vertical distance here is given by y2 minus y1 divided by the horizontal distance is represented by x2 minus x1, and that one will give us the gradient of this line. So that is how we get the gradient of any straight line given the 2 points. So what about getting the gradient using the coordinates? We have, in the previous slide, we have used the x and y, but this time I want us to have real values that you're going to use in this part. So suppose we have this point is 2, 4, and this point is 5, 10, and we want to get the gradient. So formula is change in y over the change in x. That is how we get the gradient. So our change in y will be given by 10 minus 4. That is a change in y, 10 minus 4, which is given here. Change in x will be given by 5 minus 2. That is what you get there. And when you subtract this, you get 6 over 3. Therefore, the gradient of this line is 2. So the gradient using the coordinates, again, find the gradient of the two lines. Again, this one is just a repetition of what you've done. For emphasis, we can do this too for proper understanding. So let's get the gradient of this line that is here. So we've said the gradient is given by the change in y over change in x. Change in y divided by the change in x. So for this one, you're going to get the change in the vertical distance, 8 minus 2, divided by the change in the horizontal distance, which is given by 3 minus 1, and this one will give us 6 over 2, and the gradient of that line is given as 3. Now for this line, to get the gradient of this line, we get the gradient is given by change in the vertical distance, which is 8 minus 2, divided by change in the horizontal distance, negative 3, subtracted minus, that is minus negative 1. So this one you get 8 minus 2, you get 6. Then negative 3 minus negative 1 will give you negative 2. And the gradient for that line will be negative 3. So this is just a reminder of the gradient formula. The gradient formula, which you have just looked at it in the previous slide. Gradient, don't forget this, gradient is given by the change in the vertical distance divided by the change in the horizontal distance. People who call it gradient is given by change in y over change in x. Don't also forget that gradient is the measure of how steep a line is. Now, another important thing supposed to know here is that a line sloping up from the left to the right is a positive gradient. This is the line. This line is sloping up from the left to the right, as you can see. So the gradient of such a line is positive. Now this line that is here, that is sloping down from the left, you can see this line is sloping down from the left to the right, is a negative gradient. So this one, if you find any kind of a line that looks like this one, just know that this one is a positive gradient. If it is like this one is negative gradient. Straight line equation and the gradient connection. Now, if you're given a line in the Cartesian plane, for example, these two lines that are drawn here, and you're supposed to get the gradient, what you need to do is just to obtain any 2 points. Obtain any 2 points from these or 2 coordinates from this line, and use those 2 points to calculate the gradient. Now, for this, in this case, the points have already been given in the table of values that are here. So, if I want to get the gradient of this line, I just need to pick any 2 of this line, any 2 of these points. These are 3 points that have been used to draw this line. But when I'm calculating the gradient, I only require to use 2 points or 2 coordinates. Now, for example, I can pick one here. I can pick 3 and negative 8 and 1 and negative 6. So if you want to get the gradient of this line, just say negative 8 subtracted minus this is the y coordinate. So negative 8 minus negative 6, that will give us negative 8 minus negative 6, that will give us 14, over the change in x, that is 3 minus 1, which will give us 2. So do the calculation very fast and you'll be able to get that one is negative 1. I repeat, so you get the change in y distance divided by the change in x. So the y coordinate, this we have picked these points 3 and negative 8 and 1 and negative 6. So if you want to calculate the change, you'll get negative 8 minus negative 6 will give us negative 8 plus 6, which will give us negative 2. That is for the vertical distance. Then for the horizontal distance, you get 3 minus 1, which is 2. And when you do that division, you get negative 1. You do the same to this one and you get the answer as 2. The other thing that you need to look at is the general format of any equation of a straight line, which is given by y is equals to mx plus c. This is a general format of any equation of a straight line. Let's investigate the properties. So, very important thing to know in this line, m is the gradient, then c, because c the y-intercept, or where the line meets the y-axis. C represents where the line meets the y-axis. M represents the gradient. So lines are parallel if they have the same gradient. This one is very important, as you're going to see in our next video when you're calculating the perpendicular and parallel lines. So lines that are parallel to one another have the same gradients. The ones that are perpendicular to one another, the product of their gradient is negative 1. So those are the things, very important things that you're supposed to know. So M is the gradient and C is the y-intercept, or where the line cuts the y-axis. Another thing that you're supposed to know is lines are parallel if they have the same gradient. We have just talked about it, and you have looked at the M being the gradient and the y-intercept. So here are the questions that you can try to do to see whether you have understood how to calculate the gradient. So question 1, the points 1, 4 and 3, 11 lie on a line. Find the gradient of these lines. So here you're going to use the formula that we have just discussed in the previous slides. So how do you get the gradient? It is a change in the vertical distance over the change in the horizontal distance, and you have given the formula. So you can try this one. You can also try to complete the table. This is a table of values, which is very important when you're drawing the straight line graphs. So use this equation to draw this line. You can fill the first one here, then you can maybe do the rest. So the equation is y is equals to 3x plus 1. So we can fill this. When x is negative 3, we just need to come to this equation and substitute this value of x with negative 3. So you get 3 times negative 3, which will give us negative 9. Negative 9 plus 1, which will give us negative 8. So in this part, you'll get negative 8. So you can fill the others. And also question number 3, are these two lines parallel? Explain your answer. We have just discussed on how to know whether lines are parallel or not. Then the other thing that you're supposed to do is to rearrange the equations into the standard form. We have said that the standard form of an equation of a straight line is given by y is equals to mx plus c. So these equations that you can see, they are not in that standard form. So you have to, in case you're given an equation in this form, you're supposed to rearrange it so that it can be in that form. So y is equals to mx plus c. So what you need to do, like for example in this one, you want to remain with y on this side, because that is how the standard format of equation of a straight line looks like. So you take this negative 3x to the other side, so by adding both sides plus 3x, and this is what you're going to get. The gradient is the coefficient of x, which is 3. The y-intercept, which is where the point at which the line cuts the y-axis, is 4. For the second one, for you to write this one in the form y is equals to mx plus c, you can take this plus 2 minus 2x to the other side. You get plus 6 plus 2x. Then you divide everything by 2, and this is what you're going to get. So you just need to organize the equation so that it fits into the standard format of a general equation of a straight line. Find the line parallel to y. This is the last thing that you're going to do in this section, so that in the next video you can look at perpendicular lines. So there's a question here, find a line parallel to y minus x is equals to 0 and passing through point 03. So we've just said that if two lines are parallel to one another, then it means they have the same gradient. So the line that you're going to get here should have the same gradient with this. For us to get the gradient of this line, y minus x is equals to 0, we have to write this equation in standard form to get y is equals to x. The coefficient of x is 1, therefore the gradient is 1. Then this equation does not have c, so it means c is 0. So after getting that, a line parallel to y is equals to x has the same gradient, because we've said for two lines which are parallel to one another, they have the same gradient. So gradient is 1, and that line must pass through 0, 3. It must pass through this point. Therefore, it cuts, this one means that it cuts the y-axis at 3. Therefore, the equation of that line in standard form will be y is equals to x plus 3. 3 denoting that this is the point, this is the y-intercept where the line cuts the y-axis. Thank you so much for watching.